Okay, so I'll just like kind of recall what all things we did till now. So there was a BRB bot packed malware that we are kind of analyzing right now, and we actually tried to kind of first, because we're knowing that it's a UPX based malware, we tried to unpack it using the the command line, the UPX -d, and then kind of got the unpacked malware code. And apart from that, thing is like we also looked at like, okay, when we are kind of analyzing any malware, why we need to disable the ASLR protection kind of thing for any malware. So thing is like, because the reason was that the packed malware has a kind of a area where there's unpacking, where the code is unpacked. Okay, and when that unpacking code runs, it actually tries to decode the packed version of code at a particular offset. Okay, and what happened, like, if the ASLR is active, that offset value might actually get randomized. So maybe the packer or the malware won't be able to properly decrypt itself, and also it won't be properly kind of parse in the IDA Pro. So thing is like, if the ASLR protection is active for a malware, you're saying, so what will happen, like for a particular offset, suppose I am getting a instruction like MOV A comma B. So that particular instruction will be in a different offset when you are trying on your machine. So thing is, if you disable the ASLR, what happens? The instructions are at same offset for everyone. Like if you also try disabling the malware, the ASLR protection, the offset of the assembly instruction will be same for all of us. Okay, and actually that's how the exploit, whenever the hacker develop an exploit for software, they actually try to kind of they actually favor that ASLR protection is not there, or it is somehow kind of disabled for that software, so that like when they will write the exploit, they will be very much sure, okay, that the instructions are executing at a particular offset on every machines, and so their exploit will work. Okay, but if the offset address is randomized, so it will create just a minute. So it will actually create a problem for them, and their code might crash. Okay, so one of the very basic thing that I showcased you, that was the CFF is Explorer software, by where you can just load the any malware or any software and just go to this optional header, and you can just uncheck this box, DLL can move, and it will actually disable the ASLR for you. Okay, and now the other command line was just to execute this, and maybe download this software, set DLL characteristics, and if you do set DLL characteristics -d and the name of the malware, so it will turn the ASLR off for that also. Okay, and we were then actually seeing like what's the difference coming in the strings that were being seen for the packed malware and the unpacked malware, and there was a huge difference in that. Okay, and now I will then we also looked at Scylla software, which we had used to kind of get the unpacked malware. Okay, so what it used to do is kind of what it does is like, whenever you are running any packed malware, so in memory the code will be kind of unpacked. So what this Scylla do is like, you can actually kind of dump that memory space of that malware directly from memory and just save it on a disk. Okay, so what happened is like, when you kind of dump the process code from the memory to the disk, what happened that there might be some kind of code, some portion of code, which might be kind of might have been paged out to the disk drive. Okay, and there might be some particular offset where the instruction might be missing, or maybe the kind of the setup of of the different section of executable might be kind of missing. There might be a case, but what will happen is like, if you do that for any malware, no matter you don't know what's the kind of packers or unpacker it has been used, this process will work every time. So you can dump the malware from the memory directly, and you will get the unpacked version for sure. Maybe most of the time 100%, but some of the time maybe it will be 85% or 70% even, kind of what all codes you can get. And once you got that code, you have to just follow this path, do a IIT auto search. What it will do is kind of it will scan and kind of tell you, okay, what are the DLL file that this process might need. So it will do auto search for you, and then it will kind of it will just get those DLL for you and like kind of make the offset proper of the executable. And then you kind of what you can do is you can either delete or fix the invalid maybe the DLL files if it is not detected. If like in over here in 7 of the DLLs, one didn't got detected. And once that's done, you can just click on fix dump and you will get a dump of the process from the memory. Okay, so what will happen now is, just for instance, is like maybe you might be not able to kind of execute the software. It might not run. In some cases it will run, in some cases might not run. But even though, what you can do is kind of you can quickly parse the assembly language and you can see most of the code of the malware. Okay, that okay, what all DLL files, what all functions it is kind of calling, what all strings it has, and what all registries it is kind of like changing or connecting to IP address. So those all details you will be able to get now. Okay, using the behavioral static analysis and all. Okay, so that's how it will be actually helpful for you to kind of work on any malware where you don't have kind of you don't know what's the packer in that. Okay, and I'll just quickly go to the Ollie debug now. So in Ollie debug, we were actually kind of we started the malware, and we were actually trying to kind of dump the unpacked version. So what happened is like in the UPX, when because this BRB bot was using UPX malware. So what happened is I'll just quickly search my PPT file that I have made last time. Yeah. Okay. So what I have told last time is that for this, suppose this is a malware process. Okay. And what will happen is that this blue part is the one that is like kind of unpacked code, which actually executes and it decrypted, it deobfuscate or unpack the red portion of the malware. Okay. So what happens is, so what, just give me 1 minute. So thing is like what we were seeing last time is like we uh, opened the BRB bot in the IDUP in the Ollie debug, and we were knowing that in the boundary over here, when the UPX will be kind of will the code will run, this blue portion code will run and will try to unpack this part of code. So at the boundary there will be a lot of zeros filled up. Okay, and if we just scroll the Ollie debug, and we can see there will be a jump instruction that will tell the malware to jump to the offset where the decrypted part of this code is now available. Okay, so what we have done is kind of we have put a breakpoint over there, and at that moment of time we have stopped doing further analysis. So today I will be completing that, and we will see like okay what all information we can get from that. Okay, so I'll just quickly start the VM. Okay, just a minute. Next, test. So whenever you guys also face this kind of similar problem, you can just go to the files that are created in that VM and just delete the file with ending with .lck. Okay. So I'll quickly start this one. So any questions from you guys till now?
No problem.
No problem.
Okay. Already work, and I'll just put the malware over there. The password is malware. And I have got the VRV bot, and let's go to task manager and I will just quickly check that the VRV bot is not running from beginning. Okay. And now I will quickly go to IDA Pro. Yeah, the already debug. So what happened is, like, whenever you guys also are using the Ollie debug, there might be a case that maybe the old file of any different malware that you are analyzing are still there in the configuration file. So I will let you know that what happened is, like, there is a file called that ends with extension .udd. Okay, so sometime even if you're like the Ollie debug is not behaving properly, so you can just search for .udd file and just delete that, and then the old debug will start running fine. So I'll just start this one. And I'll go to executable modules and click the VRV bot. And here we are. So here you can see that there are a lot of zeros over here, and this is the instruction where the jump is happening. So I'll just see if I have. So here's where the jump is happening. So I will just put a breakpoint over here, and we'll now quickly run this software. Just run it. Okay, so now I am in this part of code where it is kind of it will be jumping to that portion of code. And now what I will do is I will quickly go to that line, that jump. And this is where, guys, the actual kind of the code where it is like calling the unpacked version of the VRV bot from this portion. And actually now from here you can actually dump the memory space of the unpacked malware. So one of the issues that I am facing right now to show that is, actually there is a plugin called as Ollie debug dump ex. Okay, so I'm not seeing that currently in my VM. So just give me 1 minute if I have that. So what happened is, there is a kind of a plugin called Ollie dump ex. Okay, so I'm not actually seeing that. So that thing will actually come under the plugin section over here. Okay. But somehow it's missing right now. So what I will do is like, I will first show you like how the screen looks like. So when you actually execute the Oli dump EX, so you will kind of get this kind of pop-up in the Oli debug software itself. And what you can do is like, you can just click on this button first, that is get EIPS OEP. So what it will do is like, this the EIP currently is this one, which is C934CD. So that's the EIP value currently. So what it will do is like, it will kind of take that value, because this is a value of the entry point right now of the unpacked version of the malware. Okay. So what it will do is like, it will, this plugin will actually kind of like it will dump the executable from the memory using the Oli debug, and it will also set that, okay, the entry point.
But again, little voice disturbance is coming from your side.
Oh, just give me one minute.
Yeah, sure.
Okay, is it fine now? Is my audio fine now?
Yeah, Prabhu.
So thing is like, I'll quickly check later that why that plugin is missing from the Oli debug, and you can see that in the plugin tab when you go to the Oli debug thing. Okay, so what happened is like, when you click that, you will get something, a screen like this, and where you can just tell the dump that, okay, get the EIP as the OEP. So EIP is something, the current instruction pointer, and what it will do is like, when it will dump, it will like kind of make some changes in the P header, and it will tell that dump that the entry point of the kind of the uh, exact code is from the instruction pointer that kind of you have said, that is something 34CD that you are seeing right now. Okay, and then you can just click on dump, and what will happen, like, you will get a dump of the unpacked malware, unpacked version of the brbot.exe. Okay, and later what you can do is like, you can again use Scylla. So when you have got the dump file, maybe there might be a case that again it might be missing any of the, like, what all DLL file it is importing and all. So what you can do is like, again you can like kind of open that in Scylla. You can run that, open that in Scylla again. So let's I'll just quickly kind of share that. So what I will do, I'll run this, and I will go to Scylla. And brbot.exe. Okay, there are two. Okay. So this is how what happened, like when you will dump the malware. So maybe there might be a case where the DLL which are it is importing might be missing. So what you can do is again load that in a similar fashion what I'm showing right now in Scylla, and do a IT auto search that then get the imports, and then you just fix the dump, and then you okay, and then you dump the malware, the one that I showed earlier. Okay, so what will happen is now you will actually get a more better version of the unpacked version of the BRB bot, because previously we were just using Scylla, and kind of thing is like, the things that were missing over there was that we were not knowing the OEP entry. So here if you see, because we don't know the OEP entry over here, the Scylla is not knowing the correct OEP. But now, because we have kind of did analysis of that in the Oli debug, we know that what is the correct OEP entry. So what you can do is now you can also just open that Oli debug over here. You can see the value over 00C934CD. You can either put it over here, and because IDA Pro you have already dumped and set the OEP entry, so the OEP entry will be correct the next time you open that software in the Sila. Okay, and then you dump the software, and now guys thing is like you will be getting almost 90 to 95% of the unpacked version of that software. Okay, so that's one of the things that is missing from my end, is that I was not able to show you the Oli debunk deep dump ex plugin, but it's a very easy process. Just like you just go to that click and just do a 2 click, get eips oep and then dump, the process is done. But what I will do is I will take that in mind and kind of I will show that in next time how this screen looks like when you're dumping any process from the memory. Okay, so this is how kind of you can dump the unpacked version of malware. Okay, and now thing is, and these are the sequence that you have to follow. You have to kind of do a IT auto search, change the OEP entry, get the imports, and then fix the dump. Okay, so now, and what will happen, the dump and fixed version of BRE bot is no longer packed, and it will have the proper IIT structure, the table, and you can perform a static analysis of the file using any deassembler. Okay, and you can even perform a dynamic analysis and kind of the similar fashion what we have checked before earlier, that how the network connections are going back and forth. So you can perform that now in a similar fashion for this malware. Okay, so so what happened is like one of the important point is like controlling the process in Oli debug prior to dumping offer more precision. So the reason is because we now know the OEP entry point and all the other stuff. Okay, so that's why like when you kind of dump any process, first kind of at least see the code, the basic code of the malware in Oli debug or IDA Pro. Okay, so thing is, guys, I will showcase you some other stuff where the section will be debugging packed executable. Okay, so what I will do is like there might be cases, there might be a scenario that where you don't know, where the malware has not been packed by a known packer. Okay, and you don't know anything about that. Over here in the BRE bot, we had a scenario where we at least know that okay, that's a UPX and how the UPX look like, where the jump instruction are. But there might be scenarios where kind of malware, we maybe we don't know anything about the packed software. Okay, so what I will do is today I will go through a basic version of the techniques by which you can achieve your objective of kind of seeing the unpacked version of the of any malware. And later in module 4 I will be doing some more extensive analysis, and there are certain malware sample where I will be kind of doing a more extensive analysis and showing you how the a more difficult scenario where kind of you will be kind of unpacking the executable for any unknown packers. Okay, so what happen is like when you run the packed program in debugger like IDA Pro and all, it the unpacked code will be there in memory at that portion of time. So what I will do is if I go over here and I close this, and since this kind of all the BRB bot is still running over here, and what will happen if and it is held at the breakpoint, it seems. Okay, so what will happen is that even if I don't dump from here, what will happen if I just let the software run in the what you say in the debugger itself. So I can, what I can do is I can actually access the memory portion much more easier for any malware. Okay, so what will happen is like suppose for a scenario you don't know that okay it's a UPX packer, packed malware on any another packer. So what I will do is kind of I'll just see if I am using any other malware sample or it's the same BRB bot. Okay, it's the same BRB bot malware. And just imagine a scenario that we don't know anything about that BRB bot, that what packer it is there or nothing like that. So just to make sure that we are following the same scenario, what I'm going to do is I'm going to restart this thing, and I will just kind of assume that I'm not knowing anything about what packers are used or nothing like that. Okay, let's terminate now, and it is kind of loaded again. I'll quickly go to the executable modules. just click on brbot.exe, and here we are. And now I will let this process run without any kind of a breakpoint or anything like that. Okay, so let's run this software. So the software is now running without any breakpoint. Okay, and the malware is completely kind of running in the VM. Okay, now your option is to kind of check the codes that are there in the memory for this uh, malware. And because we are running that in the debugger, we will be having more kind of access to all the memory segments that this process had in the RAM memory. Okay, so we will see how we can kind of see, okay, what all codes are there in the memory for this kind of this malware, and this will apply to all the other malwares, no matter what kind of packed version or packer has been used by the attacker in that. Okay, the technique which I'm going to show it will actually work for all the malware. Okay, so what I will do is I will quickly kind of go to the PDF once. Okay. Okay, so the instruction that I need to do is, oh, okay, I think it was not subscribed again. Okay, no problem. We will take a break maybe after 10 minutes and we'll join back again. Okay, so what I will do is now, because this process is running, what you need to do, guys, is just remember that you have to press Alt plus M. Okay, so I'm pressing Alt plus M and it will show me the memory map of this process. Okay, so now I am getting the memory map of this process. Okay, and now what I will do, I will quickly check that. Okay, there's one mistake that I have done previously, that you can see that ASLR protection is on over here. Okay, so to be kind of in a safe side that ASLR protection is kind of not activated, let's quickly kind of terminate this one and terminate the brbot.exe too. Terminate. Okay, and I
So,
will.
Pragyan,
Yes, yes,
like we are disabling ASLR only for
yes.
brbot.exe, not for
Yeah,
other,
not
not
for
for other
others.
processes.
No, no, no. Only for the BRB bot, the one we are analyzing right now. Yes.
Fine.
Yeah. Okay. So let's just change the theme to a bright one. Okay. Anyways, so let's again quickly, I will just drag that malware now. And later you guys thing is like, I have a lot of sample that I have created for my own thing. So what you can do is maybe I will share some more samples and you can try on that later after this courses and all. I will share most of the samples I have for the malware. Okay, so let's unpack this quickly and put a malware. And I have here, and let's open with CFF Explorer. So I'm not using the command line now. It's a kind of just going here and clicking the DLL characteristics and checking this box. DLL can move, clicking OK, and then saving the overwrite original file. And now we are ready to go. So we will start the Ollie debug. Okay. So let's give it the admin privilege quickly. And now let's open the BRB bot packed. Go to the executables. All done. And now we are ready to run this malware. Okay, let's do this. So the malware is now running and we can kind of confirm that in the task manager. And we can see that BRB bot is running over here. And the good part is that ASLR is missing now because we have unchecked that box. Okay. And now what as I was telling, like just imagine a scenario where you don't know anything about this BRB bot, that what packers are there, nothing like that for any malware. And what I will do is, since it is running, I will quickly press Alt plus M, and I can see the memory map of that process, that what all the offsets are in the RAM memory, where the particular like kind of data of this malware are residing right now in the RAM memory. And what I can do is, because you know that since the memory is only a portion where the unpacked version of the code will be residing, so over here what I can do is kind of I can see those portion of code of memory, and like one by one, and I will be able to know, okay, what are the different kind of codes that are existing right now, and we'll get a better idea about the malware, like what are the capabilities and all. And what you can do, guys, is also thing is like whenever you are kind of analyzing any kind of memory area, okay, so you can see there are a lot of things, right? Okay, there are a lot of things, but you try to kind of uh, see that memory map portion where you see the privilege of RWE, which is read, write, and executable, because those are the pages that if you don't because those are the pages that has been set by operating system, that there will be some code in the memory, okay, at this particular offset, that can be read, that can be write, and that is executable. Okay, if this E flag is not set, the code of the malware won't be run. It will be just treated as some binary text kind of thing. But if you set that as a E, then the CPU will treat that binary is not a kind of a text, but it's kind of assembly instruction, and then it will execute that. Otherwise it won't execute that. Okay, so what I will do is kind of I am starting from this one, the UPX RWE, with the flag set as RWE. So let's see if I can kind of go to that. Okay, there are some portion missing. Okay, so over here I can see I'm getting another instruction called view in disassembler. Okay, so I hope that it's not filled with zeros. Okay, it's filled with zeros. You can like you can also do is like you can press Control A and kind of just let the software or debug analyze the memory again. So here I am seeing like a lot of codes are actually kind of filled with zero, but that's not always the case. Okay, sometime you will be actually getting the actual code of the malware. What I will do is I will again do a memory map, and maybe I will try kind of seeing other portions of the memory. Okay, and now guys I can see some instructions. Okay, some instructions over here, and this actually what I am doing right now, I'm telling you the easiest version right now, where how to kind of analyze the memory map of any process. And maybe what you can do, suppose you have got some instruction, what you can do, suppose this instruction is related to maybe a function where it is calling some other functions. So what you can do is you can quickly right click, go to analyze, uh, go to find reference. Just let me see once. Yeah, go to search for, and you can just go to the all intermodular calls option. So what we'll do is like if there is any kind of calls that are made from this portion of memory to any other functions or to any other library, you can actually see from here. But I don't think there will be something. But yeah. So once I did that, you can see that there are certain instructions that are getting called from this portion of memory. Okay, and it's something the basic one where maybe it is kind of setting some register values, closing some register key and all. So this is something that I want to let you know that, okay, this is something that you can kind of develop, that utilize this kind of technique for any kind of malware that you don't know about the pack thing. And then you here seeing this thing, because if I am able to kind of hit the right memory map, analyze the right memory portion, I will get some more actually kind of lot of other things. like uh, like what all different functions, like crypt decrypt functions, what are the strings value, what are the register value and all. So I can get it from here. Okay, so now let's see if I click it over here. Okay, and so it is calling some registry key over here, and you have to again kind of analyze the things over. So you can see that now you're also seeing the strings over here. Maybe it is trying to set some parameters under the current control set service TCP parameters, and it is setting some registry keys over here. Okay, so what you can do is kind of uh, to to get a more better idea, you can also see some Unicode values that are going through. Okay, and so this is how actually we have to analyze, like, okay, what all functions we are seeing and what all parameters are going through that. And just to kind of make a kind of a somewhat knowledge of the malware, that what all kind of capability it has and what all parameters are going to the function, like what all registry heights it is setting and all. And similarly, what you can do is you can quickly go to another memory map and kind of analyze some other portion of the code. Like suppose I go over here and view in dissembler. So I can just